Okay, so previous video was about integration, which is, remember, the opposite of taking the derivative of something. So take the integral of something. Well, that's actually should be called indefinite integration because there are no bounds on the integral. So if you wrote the integral down, there would be nothing here and nothing here, like on sigma notation when you have a lower bound and an upper bound. Whenever you have a lower bound and an upper bound, then that turns into definite integration. And so what definite integration is used for is finding area under a curve. So if you had a curve here, and you were going to go from some starting point to some ending point on the x-axis, and you wanted to find this area. Well, what you would do is take the integral of this function from a to b, and you would be integrating the variable that's in the function. So you need a dx right here. So the procedure for finding the area under this curve sounds kind of intimidating, but it's actually really easy. So let's say this curve is sine x. So of course I'd have to break this x-axis because it looks to me like this would not perfectly be sine x, but let's say this is sine x plus 3. And let's say I want to go from pi to 2 pi on the x-axis. Now, what I need to do is take the integral of each of these separately, just like with plain old anti-differentiation. There's a rule for sine x that the integral of sine x and the integral for cosine x can be found by thinking about what would give me cosine x for a derivative. So if I think about functions like sine x, the derivative of sine x is cosine x. That means the integral of cosine x is sine x. And similarly, the derivative of negative cosine x is sine x, because the derivative of cosine x is negative sine x. So these are kind of strange, but these are some formulas you might want to remember, and you could get those from just thinking about the opposite of the derivatives you already know. So all we have to do is integrate these as normal. So the integral of sine x, we can see from this formula, is negative cosine x. And the integral of 3 is 3x. And you might know that from the video on the previous video said, remember to take the integral of something, you have to figure out what function's derivative would be 3, and 3x's derivative is 3. So here's the derivative, here's the integral, and my bounds are from pi to 2 pi. Now here's the new part. Take the antiderivative, which is here, and you evaluate that from pi to 2 pi. So here's how you do that. You first plug in a 2 pi, and then you subtract that same integral when you plug in the lower bound. Now, some might say, well, I thought the integral of this needs a plus c and the integral of this needs a plus c. If you were really paying attention to the previous video, it does, but if you look, if you had a c here and a minus and another c here, those would just subtract out, c minus c. So when you're doing definite integration, if you forget the plus c's, it's no big deal. Nobody even does that, because the c and the minus c will go away. Okay, so then you're just left with evaluating these and subtracting in the middle. So I took the liberty to draw you a cosine graph, just so that you could visualize this stuff. if you're not good with knowing your trig values by heart. So the cosine of 2 pi is 1. So negative 1 plus 6 pi minus, here's where you need to be careful. This is actually one thing here and another thing here. Cosine of pi is negative 1. So negative negative 1 is 1 minus 3 times pi. So cleaning all this up, negative 1 and the minus and the 1 will make negative 2, and 6 pi minus negative 3 pi would be 6 pi plus 6 pi plus 3 pi, which would make positive 9 pi. And that's just some decimal number that you could also get with your calculator by typing all of this in, and it would give you that decimal number. So, just to go over all this again, if I ask you for the integral of this function from here to here, what that means is the area underneath this curve from here to here. So, whatever your curve is, you have a starting place and a stopping place. That's your A and your B. And your function sets the top bound. And all the area underneath here, between the x-axis all the way up to your function, is given by this integral. So what you do is you take the integral of this part, you write that here. Now, this could be a polynomial, this could be anything, and I'll work another example shortly. But you take the integral of this part, put that here, set your lower bound and your upper bound. Now what you do to actually evaluate this is plug in a 2 pi to all of this right here, then plug in a lower bound to all of this integral right here, and then you just subtract the 2. And that is how you do a definite integral. Let's say I want to find the area under this curve from 0 to 3. I first need to find the antiderivative of this function, which is rewrite your 5. Now we'll add 1 to the exponent and divide by that. Plus 6, add 1 to 1, and divide by that. Minus 10. This is really like an x to the 0 power, which is why we have a 10x to the first. The derivative of 10x is 10. The integral of 10 is 10x. Okay, now some would say I need a plus c, and you do, but in definite integration you can leave that off. Now, what you'll want to do is evaluate this integral from 0 to 3. So you do that by plugging in a 3 to all of these. So this would be 5 times 8 divided by 3 plus 6 times, this is a 27, plus 6 times 9 divided by 2, and you could have reduced this right here to be a 3, but minus 10 times 3. There's what you get when you plug in your upper bound, minus you plug in your zeros here, 0 and 0 and 0, to plug in your lower bound. And so you just evaluate these 3 to get your answer, which is 42. Now, let's see what happens if you do the integral from negative 2 to 2 of a function like x cubed. And we're integrating with respect to x. So this would be 1/4 x to the 4th, evaluated from negative 2 to 2. And some people put this evaluated and it looks like brackets. But either way, that's how you do that. Okay, so I will do 1/4 times 2 to the 4th minus 1/4 times negative 2 to the 4th. And this subtracts out to 0. And you'll notice that the reason this is 0 is because x cubed is an odd function, and these are additive inverses. So from negative 2 to 2, this area down here is a negative amount, and this area up here is a positive amount. And that's the same amount of area on each side of an odd function, so these are just going to cancel each other out. See, these areas have negative y values, so this will have a negative area, this will have a positive area. These cancel each other out. The answer is 0. Similarly, if you had like x squared for a graph and you wanted to do from 0 to 2, well, that's going to be half as much as the integral from -2 to 2. Because here's from 0 to 2, from -2 to 2, this is symmetrically equivalent. -2 to 0 and 0 to 2 are the same amount. So that's why this one here will be half of this one. So you can use symmetry sometimes to figure out your integrals or to make integrals easier. But that's integration, definite integration to find area.